computer distance, computer better. Everybody let me dance, get flatter. Computer distance, computer better.
Hello, beautiful humans of the internets. And hello to my fellow cyborgs. Hello, robots. And of course, most importantly, hello to extraterrestrials who will be receiving this message someday in the far future. I hope our species is still here to receive your wonderful visit. I am here with my robotic colleague Gopherbot, streaming to you from La Pipa in beautiful Asturias, Spain, where spring has come early and we've been enjoying beautiful weather, hence short sleeves. It's kind of nice, don't you think? Anyway, here we are today once again with some awesome and fun activities for you with hacking of different technologies based in the Go programming language and, of course, others. So this last week I've been moving, and I hate moving because I have so much equipment to move. Even with a workshop with my equipment, I still have a lot of equipment to move. And it was amazing, actually. I moved out of one warehouse where I had been keeping a lot of equipment, and I discovered literally boxes full of drones. So if you can make it over here to northern Spain anytime, once the pandemic has reached its 9,000th day, probably the clock will turn over, and you'll be able to come and visit. So come and claim your drone. I have plenty. Batteries not included, however. That's a different problem. So yeah, this week I've been a little busy, but right before there was a huge number of new commits and activity on one of my most favorite projects of all time, TinyGo. So let's take a quick look and see some of the stuff that got merged into the dev branch in the frenzy, fiesta of merge, as it were. There was a whole bunch of things that happened right before I moved. And so let's go take a look and see. One of the ones that was extremely interesting is a commit, or a pull request, I should say, coming in from Takashi Yoneda. And this has been waiting for a little bit of time to merge. It took a little bit, but it's a really cool pull request that if we go take a look, you can see some of the activity that took place before it made it. Let's scroll down here. Wow, so many activities. Where is it in here? I guess we might have to actually search for Mac OS. Let's see. There we go. So this pull request has been around for a while, and it hadn't made it in because it was relatively sophisticated. It adds basic file I/O support based on libc for both WASI and for Darwin, aka Macintosh OS. So what does this mean? So what is WASI anyway? So you might have heard of WASM, which is WebAssembly. It's the runtime of the future, which is already, actually also of the present in your Chrome and Firefox browsers and probably some others as well. And it's a runtime execution environment where you can run software inside your browser, but give it access to native code capabilities thanks to the fact that it is sandboxed. So WebAssembly is a really powerful technology. Oh, thank you very much. My producers are the best. They bring me water. They make sure that I'm on time. They're awesome. So WebAssembly is already being used for a number of different edge applications. It gives you access to things like the GPU, which you would not normally be able to get access to from a browser style of application. But that's really only the tip of the iceberg. In fact, there is a whole nother wave to use WebAssembly in different places. One of them is on servers, where, for example, the WASI standard exists for allowing you to run WebAssembly without any UI or interaction or browser at all. In fact, there's a project, I think it's called WASM Envoy Proxy or something like that, where you can actually run different proxy programs similar to like you might have done for an Nginx plugin back in the day. So you can write some plugins for your proxy in whatever language supports WebAssembly, for example, TinyGo. So anyway, this particular pull request adds the basic file I/O based on libc. So what is libc? Libc is a library for C, which is really, really commonly available on pretty much every platform. And so that is what we use for the runtime I/O capabilities in order to fulfill those when we're compiling C code. And so TinyGo can take advantage of that as well. And now so can WASI and also Mac OS code. So it took a while to get this merged in, but it finally made it, and it's actually a pretty exciting step forward to this world of server-side WebAssembly activity. So let's take a look at a couple of the other pull requests that made it in. And so there was some really great code added by our erstwhile contributor, Nurzal. So Nurzal's book is actually out. I believe it's out. Let's see if I can find the... So this is the first book about TinyGo. And I know you thought I was going to write the first book. So did I, but I was too slow, and so they were a lot faster, which is actually really good. I personally thank you for that. I'm really excited to actually read it. So you just sent a announcement a few days ago, but this is the book. It is Creative DIY Microcontroller Projects with TinyGo and WebAssembly. Ooh, you see a pattern starting to form here? TinyGo, WebAssembly, microcontrollers. Ooh, I'm getting chills. All right, so it's a book unpacked. You can pre-order it from this link, which is available in a retweet on the TinyGo Lang Twitter account. And check it out and definitely buy it. And I'm looking forward to doing that myself. All right, so they have a pull request that was added. Where was that? I had it a second ago. Where was that? I have it and I lost it. I closed it. Let's see. Pull requests that were... here we go. Yes. So Windows. I know many of you ultra hipster cool people with disposable income are using Macintoshes. And then those of us rugged iconoclasts are using various Linux. But the rest of the world is using Windows. And actually Windows has come a long way. I've actually done a lot of Windows programming, although I don't use Windows that often. I do a lot of testing with it. And but we care a lot about Windows users because there's a lot of you folks out there, and we definitely want to make sure that TinyGo works really well. So one of the problems that you might run into is we don't yet allow you to compile a TinyGo program that can actually run on Windows itself. You can run the TinyGo compiler, and you can use TinyGo to build software for microcontrollers like Arduino, or to build WebAssembly software, what we would call cross-compiling, but we cannot actually use TinyGo to write a Windows program yet. And so if you're a Windows user, you might do something that seems like it should work, like say TinyGo run some program, and naturally it would fail because there isn't that support. So they added this pull request, which conveniently gives you a friendly error message instead of a very nasty, inexplicable error message. So thank you for that. Nothing like making people's lives easier, especially, everybody, all of us. We don't have time to spend parsing pages and pages of error messages. It's best just to get right to the point. So let's see what else we got this week. Yes, team member and serious contributor, Sago35, once again comes through with some code to improve our USB CDC experience. So if you may or may not realize, when you plug in your USB port, there's a whole bunch of different communication protocols that could take place. For example, when you plug in your mouse, you're using one that's called the HID, or Human Interface Design, or Device rather. So the protocol, which lets you use a USB port for serial, Universal Serial Bus, for actual serial, is called the CDC protocol for the communication data control. And so we have code for the ATSAM D21 and D51, and also for the Nordic Semiconductor NRF 52840 chips. And all of these support the USB CDC protocol thanks to some code that exists in TinyGo. And so this pull request merges a bunch of code which was duplicated and puts it all together into a single place. That way it's a little bit easier for us to maintain. So when you plug in your TinyGo device and you want to flash it, and you type TinyGo flash, it can use the USB port to flash it. And then once your microcontroller is running, you can then switch over and just use that same USB port for serial communication. So that's a pretty great feature. And this pull request makes it easier to maintain. And then in the near future, our contributor Ardnu is actually working on a much more universal system for USB, which will allow CDC, HID, and probably the mass storage device, or MSD protocol, maybe some others as well, MIDI perhaps, and will provide sort of a shared set of capabilities which will let you write USB code on any given platform, which can then take advantage of all of these different protocols. That's something we don't have on a bunch of different hardware we currently support otherwise, like the STM32 microcontrollers. So we also have had a whole bunch of pull requests which have come in from project founder and hardcore contributor Aika. So Aika has gotten a bunch of pull requests having to do with the compiler optimizations and reflection that have been getting merged in over these last few days, or we're getting in right before I moved, I should say. And then there's some more that are currently outstanding. There was one I just merged in today, actually. That was the first one after I moved, and I was able to migrate the Tiny HCI hardware continuous integration server to its new location. And so this was the first pull request I was able to merge after getting the HCI back up. And this is actually a really great pull request whose effect is to speed up the TinyGo compilation process by being able to cache packages per package. That way, if you don't have a change in a particular package, if you're just working on modifying the code in one package, this will speed up your whole process. So it's pretty great. So I think we maybe have a couple of new pull requests that we could take a look at that would be interesting to see. What's this pull request? So this is, let's take a look and see, let's see what we got here. Well, I've got a few that I would like to merge, but need a bit more testing. Here's one from Ken Bell, who is probably our most prolific STM32 contributor. And this adds support for the Nucleo L031K6 board. So the thing about this board, it's a little different from some of the other boards. So I don't think that the changes have actually been validated by anybody on actual hardware other than Ken Bell. So we probably should hold off until it does get reviewed. So let's see if there's anything else we can bring in right now. Let's see. This Go section Pragma. What is this? Oh, yes. So this is a pull request which adds the ability to put in a new Pragma, which is one of these comments that you've seen. probably in other languages, but also in Go. Sometimes there's the Go link name, and there's the new Go embed tag, which we don't yet support in TinyGo, but we hope to very soon. So this one allows you to put a function or global into a specific place of RAM. This is important if you want to do some optimizations where particular areas of memory may run faster, or direct memory access, DMA, which may be placed into a special memory area, which is required for certain hardware peripherals require the DMA can only read and write from a particular block of memory or a block of memory that needs to be pre-specified. So this is a pull request that adds this capability to TinyGo by way of both adding this pragma and then also by adding to the linker script the necessary tag which corresponds to the pragma name. So this is some pretty advanced stuff. I have not had a chance to actually test it yet. Let's see if there's any unit tests in here to exercise it before we consider merging it. So yeah, we've got a pragma.go compiler test. So this is the test here. And it creates one of these called extern global. And then there's a couple of different byte aligned pragmas here. A link name, which we had talked about earlier, which is the Go ability to link a particular function name that's exposed with an actual function name as it's really called by the linker itself. So yeah, it looks like we've got the test for that. Here's the export for it, and then testing the global. So yeah, I think it looks pretty good. We can certainly merge this. I probably won't do it right this second, but it looks like it's okay. Let's see if there's anything else here. This is a new, faster SPI transmit function added by Sago35. This is actually a very useful looking function. What it does is it lets you transmit more than 1 byte at a time using the SPI interface if you would like to have very, very high speed display peripherals, for example. Like if you're using the Hub 75, which is the LED pixel array that's used for very large signage. That's one example. Or the ILI 9341, which is the display that we use on some of the devices, such as the Pi portal, if you remember seeing that a couple of weeks ago. So looks like, as usual, he's included a fairly hardcore set of data exports from his signal analyzer, where he's showing the different speeds for the transmit both with and without the extra code that's been added. So I think that actually looks pretty good. I might need to look at it a little bit more closely. Let's take a look at the actual change. I think it just adds this to only one platform, the ATSAM D51. That's probably the only hardware that any of us currently have that has one of these displays already built in. So I think this looks pretty good, but I'd like to, instead of merging it, I am going to ask Ika to review it, only because he's got some ideas about the SPI interface that I think are important to incorporate in any of this thinking. So I'm going to ask him for a review rather than just merge it myself. Let's go take a look at see if there's anything in the TinyGo drivers repo that we can merge. There's probably a couple things over here. So, yes. So we have a couple of very interesting pull requests coming in. This one has been a pretty long time coming, which is support for the P1AM base controller, which is an embedded peripheral device that specifically is used for kind of industrial controlling. Let's take a look at it so you see what we're talking about. This is it. And you can see it's an automation platform that has got a bit more industrial grade I/O, as they claim, which generally means 12 or 24 volts instead of just 5 volts, and usually means much more robust circuitry, usually more fault tolerant. So this pull request has actually been waiting. It's taken quite a while to get it in. There was a bunch of changes that needed to be made in order for the tests to pass, and a bit of communication that had to take place so to get the idea of how we try to work, which is atomically. So what do I mean atomically? Well, an atomic commit in a database sense would be a transactional commit where everything is all complete, all in one single unit. The money comes out of your account and goes into mine at the same time. Just kidding. But no, that is an example of an atomic transaction in the database. And when we're using Git as a version control system, it's very common that you might take a whole bunch of attempts to get to the code that you actually want to have. And you don't want to have 20 different commits that do just one thing. That the collective group of all of those is what you want as a single commit. So Quentin Mitt, this contributor, went and very helpfully rebased all of these commits to put them together into a series of commits where each one made some coherent sense. So, for example, this one adds documentation and the example program. So it updates the README and adds it there. Here's our sample program. And you can see that it is using some built-in devices that are only on this P1 AM base controller itself. So then based on that, it's talking to that controller and then getting the switch states, and then I guess it looks like setting them and then reading them back. So that's good. We need an example program. So it's very helpful that this has been rebased now into a series of commits where each one does something specific and atomic. So now I think we can actually merge this. So thank you. We have to say thank you. Thank you to Quentin for making all of the requested changes. And now merging at long last. All right, and we can rebase and confirm, and voila, another awesome contribution from one of you wonderful peoples out there in Internetlandia. Thank you. So let's see if there's anything else in the driver's repo that we could maybe do. So here's one that Ika contributed that I've been looking forward to quite a bit, which is we're trying to switch over to use interfaces for everything in the driver's repo instead of using direct references to the machine package. So, well, what is the machine package? That is the hardware abstraction layer that is built into TinyGo. So why do we not want to use that in the driver's package? Well, there's a couple of reasons. One of them is that if we use an interface instead, it makes it a little easier for us to write unit tests. For example, let's take a look at this ADT 7410. So the ADT 7410 is an I2C temperature sensor, and we've been able to write a unit test for it by using the quick test package, which is just a normal, standard, relatively well-known, I should say. It's not part of the Go standard libraries, but a lot of people use it, as we are ourselves. And so we're able to write unit tests that are just regular Go, so we can test and exercise using some mocks that we've created for I2C devices in the TinyGo drivers repo. And it lets us test our code at a much more fine level of granularity than some of the other ways, which we also do in our drivers repo. For example, smoke tests. We do smoke test builds for each of the drivers on one or more of the different supported hardware platforms. But this way it allows us to have kind of a more testing in depth strategy. And so this pull request that Ika has made is one that specifically adds an interface for UART objects similar to the interfaces that we're already using for the I2C and SPI buses, and it will make it a lot easier for us to write unit tests using QuickTest in the drivers repo. So let's go take a quick look and see what actually does that mean. So the first change is that instead of using here's our package uart.go, which defines the UART interface, which is an IO reader and writer, and also supports the buffered function. So that's kind of the minimum necessary functionality to support the machine.uart type. And there's only a couple of places where that's being used in the TinyGo drivers repo right now. The first one is the SPAT driver. So the SPAT driver is a driver that is used to communicate with the ESP8266 or ESP32 firmware that's built in for Wi-Fi. So the ESP32 and the ESP8266 from ExpressIF, both of those are typically most commonly used as Wi-Fi coprocessors. So you can also use them as a separate microcontroller. We have some very rudimentary support right now for actually compiling and running TinyGo programs on the ESP32. However, the most common use these days, currently, is when it comes from the factory, it's already been preloaded with this ESP-AT command set that let you access the different Wi-Fi and also Bluetooth capabilities. So what do you mean AT command set? Well, if you pull out some of the books of our grandfathers or our fathers, you will see that modems, the devices that used to make phone calls on our behalf and connect computer to computer directly over phone lines, well, we still have modems now. These modems are usually cable modems. They're not telephone line modems. But from the original Hayes 1200 baud modem, I think it was the Hayes 1200 baud modem, there was a set of AT or attention commands. All of these are text commands that start with the text AT, then a plus, and then some letters that correspond to something you want the modem to do. In this case, it's not a modem. We're actually telling the Wi-Fi adapter to do something. So, for example, if I want to see if my Wi-Fi device is, if I want to get a list of the different access points that my Wi-Fi device can see, I use this AT plus CWLAP command, which is CW list available APs, access points. All right, so there's a whole bunch of these, and it is a UART interface typically that is used to communicate between the microcontroller that is the brain of the device and the ESP32 or ESP8266, which is the Wi-Fi coprocessor. So that's what this SPAT package does, is it lets TinyGo use that for Wi-Fi communication. So all that we have to do here is there's really just a couple places that switches the bus from the drivers or machine.uart to drivers.uart. And then same thing for the GPS device. So similar, actually, in many ways, GPS device uses a set of AT commands, usually as well, that are part of specifications that are, more or less universal, but not always, but pretty close. And then there's another standard that they use called NMEA. So NMEA is a combined electrical and data protocol that's used for localizing you with a GPS or sonar or radar device. These days it's most commonly used with GPSs, sometimes with autopilots. So this is the two protocols that are used for communication with the GPS, and you can use them both over UART. Hence why the code here replaces the machine.uart with drivers.uart. So it's pretty straightforward, and all the tests passed. So let's merge. Yeah. This is going to make, next step, of course, is actually add some unit tests. But we'll leave that for another day. All right. Cool. We've got a couple drivers updated. Finally, that long-standing pull request that, wow. Talk about patient. I really, really appreciate how patient some of our contributors can be. We're not just being picky for picky's sake. We are really trying to be good shepherds, if you will, greenskeepers. We speak for the trees. Our job is just to try to make it so that everything continues to work for the most people possible. And as a result of that, we usually have to do extra work to make changes, to make sure that coding standards are conformed to, that some smoke tests or unit tests are added, that there's not too few or too many commits to accomplish the task that pull request is intended to accomplish. And so we're running our unit tests now here on the drivers repo. So the drivers repo runs its unit tests by pulling down the latest and greatest TinyGo development version of the Docker repository, Docker image, and then it executes all the tests against that most recent image. So that way, whenever there's a change to drivers, we make sure it's synced up with the latest version of the TinyGo development. The idea being that whenever we release a new version of TinyGo itself, we generally will also release a new version of the drivers at the same time, and that those two things are generally guaranteed to synchronize together. So this is one of the ways we make sure that it happens. And you can see that we run our normal unit tests, of which we have some, but not enough, obviously. And we also run our smoke tests, which we have at least one for each supported device. So it's part of our testing in depth strategy. Probably the next step beyond this would be to actually test on real hardware, to set up a tiny HCI build that was able to, we could wire up the hardware with actual sensors, one of each kind, and then try to exercise it. That would probably be an excellent exercise and something we can work on in the future, for sure. But I'm not going to be able to do that where the lab is now currently, my home lab, until I get some faster internet. So right now, I am running on wideband antenna. Wideband antenna. Yes, it is rural internet. And that's a little tricky because it is much, much, much slower upload speed than it is download. That's kind of unfortunate. But where I am, the copper wire needs to be repaired and needs a new pole or two or more put in before that can happen. So tragically, that may not happen that soon. But luckily, there's another hope. There's another hope. And what is that hope? Well, you know, you may have heard of SpaceX. Who hasn't heard of it? If you haven't heard of SpaceX, I mean, even alien, you know, uh, extraterrestrials who are sneaking around gathering information about us Earthlings. No, I don't think they're here. I wish they were here. Come save us, please. Um, so anyway, as I was saying, SpaceX, one of the most famous companies on Earth, from my favorite evil genius, Elon Musk. So SpaceX is got a company that is the kind of, I don't know if it's a spinoff or a separate company, but it's called Starlink. And Starlink is launching satellites into orbit generally every week or two. And here is a video from their last launch of 60 satellites.
The satellites are slowly separating from the second stage. Shortly, they will deploy their solar arrays, and over the next few days and weeks, they will distance themselves from each other and use their onboard ion thrusters to make their way to their operational orbit.
So every time they have one of these launches, I say to myself, these 60 satellites are almost for sure, some of them going to reach their station above where I live in Western Europe. And one of those satellites is going to be uniquely positioned at a slightly southern azimuth relative to the horizon for me to then position my Starlink satellite dish that favorite evil genius Elon Musk will hopefully be sending me very, very soon, to be pointed towards this Starlink satellite and giving me 100 times my current wideband internet access service. Yes, 100 times, and going through space. So that's really cool. So that last launch was March 24th. I'm sure there'll be another launch coming really soon. And I can't wait because, I mean, really, I need this. So there's been a lot of cool questions coming up this week in or actually last couple of weeks, I should say, coming up in our Slack room. So if you don't know about this, the best place to reach us on real time is currently on Slack. So I was trying to get us to use IRQ. No, just kidding, IRC. But the world has gone towards Slack, and the Gopher Slack actually has a lot of different channels that correspond to different projects and sub-interests within the overall Go community. And TinyGo is a part of that. We currently have 747 members, and one of the newest ones could be you if you come and join us. So we have a link on our website. It does require an invitation. The Gophers Slack is curated. It is carefully managed by a group of very friendly, open-minded, and how should I say, protective of our community. So it keeps trolls, meanie people, haters, spammers, and other people who would like to abuse our goodwill, collective goodwill, I should say. So luckily, these wonderful people do all of the hard work to keep the rest of us so we can just enjoy the community at large. So you can click on the link that's available on the tinygo.org website, and that will take you to a place where you can request permission to join the Gophers Slack. So if you have any questions, that's a really great place to ping us. Generally, one or more of the contributors are around. Since, as you know, we circle the globe, anywhere on planet Earth that you are, there is somebody, no doubt, who is a TinyGo user. Maybe very sparsely distributed, but there's someone in that time zone. Okay. So anyway, one of the things that came up in the Slack this week was a question about how you can use the displays that are supported in the TinyGo drivers repo, of which we actually have a few, right? So we have a number of these displays that are supported. And if we take a look at the driver's repo, they're all listed. And we can see that we have, for example, we have the Hub 75 LED matrix. That's not really a display. The ILI 9341 TFT color display. Color. We got the PCD 8544, which is relatively rudimentary kind of display. We have some of the fancier OLED displays like the SSD 1306, the SSD 1331. Then we have some TFT color displays like the ST7735 and ST7789. So yeah, I mean, we have like a bunch of displays. So this person's question was, great, you have all these displays. How do I display something on them? Like text, for example. And this is the reason why actually we have the project called TinyTerm. I mean, we also have TinyFont. We could start there. So TinyFont is the package originally created by team member Conejo Ninja, Daniel Esteban, who is hanging out with his lovely family there in Murcia right now. Hola, queridos. So, so this is a really cool package that sort of in the style of the Adafruit GFX library, it takes a bunch of open source fonts and it basically compiles them and turns them into Go code, which you can then just call and, do relatively normal type of operations just using these fonts. Let's look at one of the examples just to give you a quick idea. So, a relatively simple display example would be this. So we include the tiny font of our choice. We initialize the display, and then we can use tiny font to write some text like hello, Gophers, in different colors on the display in different locations. So it's pretty low level in the sense that you do need to know exactly where you need to put the text, but you don't have to draw each letter or anything like that. It will draw it for you. And this is actually what I used in my demo for the Tiny Flight Controller that I've been using every week to demonstrate the TinyGo Bluetooth Low Energy stack. So that actually uses TinyFont for its display. But there's another thing that's built on top of TinyFont, which is called TinyTerm. So TinyTerm is a kind of terminal emulator written in TinyGo that is designed to use TinyFont and create different kinds of console type of interfaces, one of which you see here. It's kind of this one would be displaying the 256 color ANSI escape codes. So we've got a couple of examples here. This is the basic clue. Let's see what's in there. So what is the clue? So the clue is that really cool little board from Adafruit based on the NRF 52840 chip from Nordic Semiconductor. So I can get the focus. There we go. And it has a bunch of built-in sensors, and most importantly, it's got a built-in OLED display. So this is what I was using in my demo that I showed in my FOSDEM talk, Go Without Wires, as a BLE scanner. So I thought we would take a look at how that was built and take a look at the capabilities at the same time of TinyTerm. So first let's go and take a look at this code now. That is the basic clue code. So the first thing it does is we see that we are using the few of the Go standard packages, FUMT, the image color package, Then we have the TinyGo machine package and the standard time package. Then we add, from our drivers package, the TinyGo ST7789, which is the display that is built into the Clue. TinyTerm, which is the terminal program that we are talking about right now. And then one of the fonts, which is built into TinyTerm, called Proggy. So we will initialize the display, and then we'll initialize TinyTerm by passing it the display. So TinyTerm is essentially going to take control over the display, and then we can call the terminal's higher level interface to actually do interesting things, like write text to the display. So then our main function, first we configure the SPI interface, we configure the display itself, then we fill the screen with black, and then we configure the terminal once the screen is filled with black, and then repeat endlessly the time to the terminal display. All right, so let's see if we can actually get this to work. So I guess first we'll open up, I'm going to switch to use Go 1.16 in my GVM. And let's go into my development directory where I keep everything. And let's see if, probably under TinyGo, TinyTerm. Yep, that's it. And so let's take a look and see what we got here. Oh yeah, it was that demo that we're going to look at, which is basic Clue. So if I TinyGo flash, target Clue, and we'll see examples. Basic Clue, I believe, would be the name. Yep. So let's go and plug in the Clue. If I have the Clue, there we go. So let's plug in the Clue to the computer. And then get a little focus here. Whoa, it's blurry. Good enough. And then let's go back over and see if we can actually flash it. So it's going to download the latest TinyGo drivers. I think those are the latest drivers. What are the latest drivers? Yep, those are the latest drivers. Yeah, it looks like it worked. So you might notice that it's actually upside down. The reason for that, let's see if I can adjust my angle here a little better, and my focus. We have to get really close. It's very small. I wonder if we should have made that bigger type. I can't even focus it. Let's go and change that so that we can actually see it, because that would make it a lot cooler. So let's see here. Let's go into our TinyTerm. We need to open it in my editor, which is Code, VS Code, and we'll go into our examples for the basic Clue. And we can see here that we're just printfing that time. And that our terminal, you see that when we configure it, the configuration struct includes the screen bounds, which is if the screen size is smaller than, or the bounds of the screen is bigger or smaller than the physical display area, the font that we're using, the font height, and then the font offset. So let's increase the font height to, let's say, 14, and the offset to 8, and see what happens. I don't even know. But maybe it'll be bigger. So let's go flash it. See if it works. Might take it a little bit longer to compile because, well, no, actually it was pretty quick. Oh yeah, that's a lot better. I can actually kind of see that now. How about you? So that is displaying the Unix time every second or whatever through TinyTerm to the display here. So you can see that is pretty useful because that's a much higher level interface than just drawing the text to the screen manually. So yeah, you can see where that's pretty useful. So let's go and take a look at my code example that I showed at FOSDEM, which uses TinyTerm and also uses the Bluetooth scanning capabilities of the Clue. So let's take a look here. So here's the demo, and it looks relatively similar to what we were just looking at a moment ago as far as the basic Clue example. So we've got the FUMT package, the image color package, the TinyGo machine package, and the time package. And then we got a few other packages. We got the TinyGo Bluetooth package, which we did not include in the basic demo. But then we've got the same other three things that we did, right? The ST7789 driver from the TinyGo drivers package, TinyTerm, and then that same font, Proggy. And so this demo, we define the device and we define the Tiny Terminal based on that display. Here's our black background and the font, which is the Proggy font. And then adapter equals Bluetooth.default adapter is referring to the built-in normal default Bluetooth adapter in the microcontroller itself, inside the Clue. Remember, the Clue uses the very, very awesome Nordic Semiconductor NRF52840 chip. And this chip is a microcontroller with a built-in software radio that can be used for, among other things, Bluetooth. So that's how we can turn this little tiny board into a full Bluetooth scanner. So let's go to our main function here. So first we're going to init our display. Oh yeah, they're bringing me the big water now. They're like, all right, this guy seems thirsty today. It's really hot. One of the days I moved, it was 30 degrees. 30 degrees in northern Spain. So our main function here is we've got our display. We init our display. We've got our must function, which, if you recall from some of the other demos, is sort of a little idiom that we've got to ensure that something does not return an error. So it must enable the BLE interface by calling an adapter.enable. And if it doesn't, then it will just output endlessly to the serial port the error that it incurred. That way we have a way of trying to troubleshoot this if it fails. We can just see what's coming out the serial port. And then we'll start our scan. This print line here outputs to the serial port. And then this one here will output that same data to our TinyTerm, right? And then we actually start scanning. So our scan handler is what gets called every time that the TinyGo Bluetooth stack is able to detect a new device, right? So the scan handler here, it gets called with the Bluetooth adapter responsible, and it's always going to be the default adapter currently, but if you had more than one adapter, then that would be supported. And then a Bluetooth.scan result, which is the device itself that's actually being returned. So we will print line the information about it, which goes out the serial port, and then we'll also funct.fprintf. So this is just part of the normal funct package, which is part of the normal Go standard library. And this does a formatted print, fprintf, to a file interface, which is what our terminal is, right? It acts like a file. And we create a new line and then a string, a number, and a string. The first string being the address. The second one being the relative signal strength indicator, which is, as you might guess, a relative signal strength, basically kind of giving you an idea of, given the overall strength of the software radio involved, how good is the connection, or strong is the signal, not necessarily how good the connection is, just how strong the signal is. And then the device's local name. So both of those will be output on the serial port and on the display. And then the only other thing we have to do here, remember this is a Bluetooth scanner on a microcontroller in less than 80 lines of code. So then we init display, which just initializes our SPI interface, which is what the display is connected to, initializes the display itself, and then configures it, which you see here we are setting the rotation to 180 degrees. The reason for that is this particular display can only do scrolling in one direction. It can't do scrolling in two directions. And as a result, we actually have to flip it over so we can scroll the information that rolls by using the hardware accelerated scrolling instead of redrawing ourselves each time, because that would be very slow. Instead, we just change the frame buffer inside of this particular device, and we get a really smooth scrolling, right? I mean, that's what we see on our time demo here. It scrolls really smoothly and quickly. So we're going to see that same thing now, but instead of just seeing the time, instead we'll see all the different Bluetooth devices, whatever they are, that are within scanning range. So let's go over to our terminal, and we should be able to just TinyGo flash. Our target, again, is going to be the clue. And we're basically just flashing the current program, current directory, everything that's in there. So what happened here? I know I've updated a couple of things since the time when I showed this demo to the latest development version. I assume we're using the latest development version of TinyGo. So TinyGo version, yes, I'm using the latest version with Go 1.16. Let's take a look at our code. This might be related to, no, that's not it. So let's see. This is good. We're finding problems, potentially. Does not match function signature. Okay. I think the problem here is that we need to update this repository to use a newer version of the TinyGo drivers package. So at the time when the demonstration was being shown for FOSDEM, the TinyGo drivers package was back here in 0.14. So if we want to actually have this work, we need to go get update tinygo.org/x/drivers. And this way it will update the drivers package, and actually, and you can see it updates it from the pre-release SHA version to the actual tagged release v.15.1. So now if I try to compile this again, probably work a little better. Since the function signature did in fact change. Well, same problem? We might need to do a TinyGo clean. And then we can try again. Nope, same problem. Okay, so let's see. Set pixel optimizations caused a verification failure. So it says that the call parameters does not match the function signature. Well, that's a pretty straightforward error. And it says that it's the set pixel command that's part of the ST7789 device. So let's go and actually take a look and see what does that device currently expect. So if we go look at the TinyGo drivers repo, and this is the latest release version, and we want to go look at the ST7789, actually, I think the problem is not that. I think the problem is that I maybe need to get also a real full release version of TinyTerm as well, which also updated. So let's go and get that, because that may be what's actually calling. So if I say go get update tinygo.org/x/TinyTerm, that should hopefully get a reference to the latest version of TinyTerm that I believe should include the correct function signature for the ST7789. Okay, and so we see that it did in fact update it. So let's try that one more time. Same problem. Well, let's see. It worked when I ran it. We need to change directories into the scanner BLE. There we go. Oh, that would help if I... There. Maybe we'll still see that same error though. Okay. So it says that the function signature is different now for setPixel. So let's go and see if we can find that. First of all, let's go to the drivers repo, which I do have open. And let's go to the ST7735. And let's look at the setPixel. So setPixel, here, is this the latest version of drivers? Probably. Let's go and look. Go to the drivers repo, and we are in the development branch, which has got most of the latest changes here. One of them is that the ST7789 updated to match the ST7735, which is, that is correct. There were some changes that we had to make in order to bring the interfaces into compatibility. And one of them was not setPixel. So, okay, that's very interesting. Well, actually, I have another thought of what this might be. Slightly different than what we were thinking, which is related to this. So, just recently, in TinyGo itself, a change was made in the development branch And that change has to do with the I2C interface and never using, under any circumstances, a pointer to it. Instead, let me find the actual pull request itself so we can take a closer look. If I say I2C, then here we go. So now, or sorry, I misspoke. What I meant to say was that instead of using a reference type, or value type rather, instead we're going to use a reference type. Meaning, instead of passing the actual I2C interface, we're going to pass a pointer to it. And so this change just got merged into the TinyGo dev branch. And I probably need to pull it. Pull rebase origin dev. Oh, wait. Let's go over to the TinyGo repo. Or a directory with the TinyGo repo, I should say. So we get pull rebase origin dev. And that will pull down all of the latest changes. Wow, lots of them. And if I run make will build TinyGo using the local LLVM install that I currently have, which is LLVM 11. And it should also use the version of Go that I have installed, which is Go 1.16. And once it's able to compile the compiler, then I just need to copy the executable into the bin directory that GVM expects. The reason is that I can't just do a Go install is because Go install would expect that to be placed into a different, or sorry, I could just do Go install. Go install is GVM aware, and you don't have any problems if you say just Go install. However, I actually want to build it against the local install of LLVM 11. So in order to do that, I have to do this manual copy. So if I say copy, you can see I've done this before. And then if I just run TinyGo version, you'll see we're running the 18 version dev using Go 1.16 and LLVM 11, which is what we were trying to do. Okay, so let's go back to the original task at hand, which was we were trying to compile my demo for the clue that I was showing at FOSDEM back in the beginning of February. So we ran into the problem that the pair that the function signature had changed. And so if I TinyGo clean, so I can get rid of my cached or anything, and I try to build it again, let's see what happens this time. Same error. Okay. So the function signature it's expecting are four integers, it would appear. And the function signature that's being used by TinyTerm is what? Let's go find out. So I've got TinyTerm open, and if I bring up I already have it open in my VS Code editor. So if we take a look at TinyTerm here, and so it did work on the basic clue example, right? Let's run that again and make sure it still works, now that we've updated a few of these other things. So I'm still in TinyTerm, and I should be able to just do this same compilation, and it should still do all the same things. And it appears to have worked. We see that, yes, we are getting the time. All right, so that's good. Now we just need to go and compare our differences and figure out what we need to do to make sure that the correct versions and the correct signatures and everything are in place. So if we go over to our scanner BLE. So Bluetooth, that's probably okay. Drivers, we know that's the most recent. TinyTerm, we know that's the most recent. We could also try go mod tidy. So the go mod tidy command generally will clean up all of your dependencies and pull in versions and updates. So let's go to where our demo is, and go mod tidy. So it's tried to update all of our latest and greatest stuff. Hit a few errors because of not being able to find the machine package, but it carries on, and so everything else seems like it should be okay. So try again to see if anything else happens. Nope, same thing. Okay, very good. Now let's go into, we know that TinyTerm itself is good. How do we know? Because we actually saw it work in this demo a minute ago with the basic clue. So let's take a look and see if we can figure out what exactly is different here versus the other one. So one difference quite clearly, false alarm. So this is the clue. This is its initialization right here on SPY 1. And where is that set pixel command used? Because that's the one that's actually giving us the error, right? So if we go and we look for set pixel and we search for it in the TinyTerm repo, we should be able to find did I not spell that right? Let's see. We're in TinyTerm. It was complaining about set pixel. That part was for sure. And the only place where set pixel is used is where? I don't think it's here. It's not used here anywhere. We know that. Okay. Oh, it might be that I have some, let's go back to the TinyTerm project. I think I might have, I guess files to include is, if we go, actually we need to, no, it's the whole project. The only place it would be here, really. Ah, I know what it is. It has to do with tiny font. That we actually need to probably rebuild the font. Let's see, how can we do that? Because I copied the, if we go and we look at our scanner, did I copy that? No, I did not. Okay, no, false alarm, that's not it either. That is not it either. So let's see, we'll keep looking. We got our drivers, we got Tiny Font 201. Is that the most recent Tiny Font? I'm not sure. Let's go look. It is indeed. That's the most recent release. Okay. So that should be all right. So let's go back and take a closer look here. So, So our problem is that it thinks that the function signature for set pixel has 4 parameters, and when we went and we looked at the actual driver itself, we see it only has 3 parameters. Let's go look at this one here. This is a similar display, kind of a sister display, if you will, the ST7789. And so when we were looking at our Tiny Term demo, our basic clue demo, we are in fact initializing the 7789 on SPY 1 with those expected parameters. So let's go over to our demo here in the scanner BLE, because we should be doing, essentially the exact same thing, right? We should be able to, we want to display with those same params. And you see that it is in fact all the same. So that is not the source of our troubles. Let us seek on. Going back to the Tiny Term. So after that, we've got our terminal, which we're just setting to that display. I think we are in fact doing that. We'll go back over here. And we are setting our terminal to, wait, where do we do that? Right here. We're just doing it at this time when we're actually defining the variable. And that's okay too, right? Because we're not actually doing anything with it yet. We're just setting a relationship between the Tiny Term and the display that it's going to be showing the text on. So far so good. Seems like it should be okay. Because our problem is that it's actually not even compiling, right? Because it thinks that there's something wrong with our... And what version of Go am I using here? And what version of TinyGo am I using here? Yes, all the latest versions. That should be okay. Because it says that is definitely the set pixel, and it definitely expects there to be 4 versus 3. So that's a little odd. I wonder why that is. I suspect that we need to try the following. Let's remove our Go sum file. And then now when I try the build, it should download all of the dependencies. Oh, sorry, we have to actually do a Go, let's see, how can I go mod? Download, that's it. Go mod download. That should go and it should pull down all of the modules that we need. Didn't say anything. Let's take a look at our Go sum file. Actually, we can just look at it in our editor. Probably be a lot easier, right? So if we go to our Go sum file, we'll see it did update a bunch of our references, but the one we care about primarily is TinyGo drivers. And it did update that to the latest release version. And TinyFont is also the latest release version. So, yeah, why is it not liking that one function? That's a new problem. So, just to take a look, the original demo that I showed used this makefile, and the makefile, all it did was change directories to there, flash it using basically the same command we're using now, and then change directories back. So if we cd demo scanner BLE, we're starting in the same place. And this does the same thing, it just dash size short would show us the size of the generated file, but it's still not actually getting that far. It's running into this problem in the driver's repo for the set pixel function where we can't actually see why that would be. So, interesting problem. I'm not too sure right this second. So one thing we can try generally is if we go back to the previous version of Go by using GVM, Go 1.15, and if I do a TinyGo clean, to clean out our cache, if I just run TinyGo version, you'll see I'm running the previous, an older build of TinyGo against Go 1.15. So let's take a look and see if maybe that has anything to do with it. Nope, different problem. Oh, right. That's because we'd actually need to go and do a rebuild of TinyGo. We could do that. Actually, let's do that. Let's go back to Go GVM, use Go 1.16. So we're using the latest Go. And then let's go back to the TinyGo, my project directory. Let's check out release, git pull, rebase, origin release. So we pull in the latest release bits. I already had them. So if we make, which is going to, again, run our make task, which will go ahead and do a build of TinyGo using our local subdirectory with the LLVM install, LLVM11. But this time with Go, with the release build. So let's take a look and see if there's some type of problem, which is a regression bug and is shown up in between the last release and the current development of TinyGo. Because it's looking a little bit like that, possibly. But we'll see here in a brief moment. So yeah, that's always one of the more interesting parts of maintaining a rapidly changing piece of software. All right, so we'll copy that build and then TinyGo version. We're now running 0.17, which is the last release version. So if we go back to our demo here and we TinyGo clean, I think TinyGo clean cache. No, just TinyGo clean. That's a Go clean cache thing. All right, so let's just TinyGo version just to make sure. Whoa, oh, Tingyo. Sounds like a cool piece of software, but that's not the same one. All right, TinyGo version. There we go. So it's showing us that it is the release version using Go 1.16 and LLVM11. Okay, so far so good. Now let's try again. So that succeeded. And if we go over to our micro, you will see in very, very small fonts all of the Bluetooth devices that are currently within range of the Bluetooth radio. And you can see the MAC address, and you can see the relative signal strength indicator. So that's very cool. And also, but somewhat less cool, is we've just identified some type of regression bug in between the last release version of TinyGo and the current TinyGo development branch. So that's not cool. What do we do? Well, one thing we can try is we can try git rebase, or sorry, not git rebase. Well, let's just take a look first before we go into git bisect is the command. But before we go into a git bisect session, well, first of all, what is git bisect? So git bisect is a very useful command for when you're trying to find a problem that has been interjected. Let's see if we can find a picture. Sometimes a picture is pretty good. Yes, this one looks decent. So when we need to figure out that between a working piece of software and now something has gone wrong in one of these commits, how do we find it? Well, we could just go one by one, starting with the known good commit and just trying each one. But if you have a lot of commits, like we actually do, if we take a look and we see how many commits do we have between the current dev branch and the release branch. Well, I have both the good and bad news to tell you, my friends, that we have 63 commits ahead of the last release branch, and somewhere in one of those commits is the code which is causing this problem. How terrible. At least that's what it would appear, right? We think that's what's going on here. We went back to the previous TinyGo version 0.17, and we were able to build it. But when we tried to do the same thing with an earlier version of TinyGo, which was the subsequent version of TinyGo, we got this problem with call parameter type does not match function signature. And it seems like it's done some kind of odd thing with the signature on the set pixel, which doesn't actually match anything in the interface of said set pixel function. So we can use git bisect in order to go, and instead of just looking at every single one of these functions one by one, instead what git bisect does is you tell it the first known good, you tell it where it's bad, and then it starts bisecting, meaning splitting in half. So the first step it will try is a commit somewhere halfway between the known good commit and where it's for sure gone bad. And you'll give it a try. If it works correctly, then it'll try the bisect again, this time halfway between that known good point and the known bad point. And this way it can substantially, if you've ever written a cell-reading algorithm, you'll know what I mean, you substantially reduce the number of tests that you're going to have to do by bisecting and then using that information to do your testing with. Otherwise, with 63 commits, this could take a while. So let's go and see. I've seen a lot of cool git bisect. That's a really old one. That's probably pretty good. Hasn't really changed. So one of the ways we can always use git is we can use git bisect, or I think it's git help bisect. If we say git help any command, it will show us the man page for it. And so it's got different subcommands. If we say git bisect start, then it will start on the latest commit. And we say git bisect bad, tells us that our current one is bad. And then we say git bisect good, well, a known good commit, which in our case would be that last release tag, right? So let's do it. Git bisect start. So now you'll see that we're bisecting. So git bisect good is the V0 17.0, and then git bisect bad is our current. Oh, whoops, we started this wrong. I should have been over in the dev branch before I started this. Okay, so I think it's git bisect. It's git help bisect too. I think it's terminate or stop, or let's see here. Reset. Yes, git bisect reset. Okay, so let's try that again, this time from the dev branch. All right, and we can see that, yes, we are on that latest commit, which runs enter p per package. And so if we git bisect start again, and we want to git bisect good from the V0.17.0, which is our last release, because we know that's good. And then what's our current commit? It is this SHA right here. So we say git bisect bad this commit, the one that we're on right now. All right. So let us begin. So it's moved us over to this commit here, 71 D1B70, which if we scroll down, there's a lot of commits. Oh, wait, no, that wasn't it. 71B10. Wow, that's a lot of commits. That's too many to scroll, but you get the idea. So we're on this only run tests on LLVM 11 or above, right? That's what we're trying to do here. So if I make, which will build my TinyGo using the correct version of the LLVM and using the latest version, the one that's currently active of Go itself, which will be Go 1.16. So it is unfortunate we have to build the compiler to do this git bisect test, because it in fact does seem to be some problem with the compilation, right? It's the actual compilation process where it stops. So we'll copy our build version in there, and we say TinyGo version, just to make sure that we are in fact looking at the version we care about. And you'll see it is after 0.17, one of the dev versions. Which one? The SHA for 71D1B70, which was in fact what it promised us, right? When we started our bisect, and there it is. When we started our bisect, it said it was going to switch to that SHA, and in fact, that is the SHA we're on. We know that because the TinyGo build process told us so. So now we're ready to go and give it a try. So if we go over to our demo and we try to compile the code, let's see if it works. If it works, then the problem, okay, so here you see it failed. That means the problem is before the commit in question, before the commit that we currently have in our TinyGo bisect going on. All right, so if we say git help bisect, so we can again see our commands. So once you find one bad and one good, right? So now we try it out, and if the current one is good, we say git bisect good, and if the current one is bad, we say git bisect bad. Right? Makes sense. We just keep bisecting from where we are. So since this one is bad, we say git bisect bad. And now it'll switch to this commit. And we do the same thing again. We make, and then we try the build. And so we keep doing this until we find the actual commit, which is the first one which breaks this functionality. And that's what we're trying to achieve here, right? Out of those 63 commits, instead of just starting with the first one right after release and trying that, and then the second one, and then so on, instead, it gives us the opportunity to do something that's a little more practical, which is slow down that, or shrink the size of space of the things that we need to check. All right, so we copy again. We go back to our demo. We try the flash again. Let's make sure we TinyGo clean. That way we don't end up with any extra cached stuff. Try the build. And let's see what happens. Will it make it? Yes, it builds. Okay, so, and it also runs. So that tells us that when we go back to our TinyGo project, we want to say git bisect good. Okay, so now it's switched over to this SHA, and we make again. You're starting to see a pattern here. So we're zeroing in on the problem. We're homing in on the specific commit, the first one where this fails to build. And then once we've done that, we'll enter an issue on the TinyGo repository's issues that explain that this particular thing is failing and how on the specific commit that's causing the problem. That's the only way we'll ever be able to figure out exactly what the issue is. So we copy it in place. We go back to our demo. We clean. We flash. And we see what happens. Okay, so this also builds, which, by the way, you may notice that it's just a little tiny bit smaller. And yes, it still works. Doesn't just build. So now we go back again. And we say git bisect good. So you'll notice now we've homed down really tightly. There's only 3 revisions left to test after this. So roughly 2 more steps. So we're getting pretty close. So let's make again. Now we started with 63 things to check, and now we're only down to 3 revisions left. So you can see this git bisect thing is pretty cool. I don't know how else you could do this. You could just go through it in the brute force way. Not actually that practical with this many commits. So let's go back to our demo. We clean. We'll try the flash. We should be getting pretty close to the problem if I didn't mess something up. Okay, so this is building. And does it still work? Still works. Okay, so we're getting pretty close here. So now if I git bisect good, because that one works. Builder, compiler, compile and cache packages in parallel. Very interesting. So let's TinyGo. We got to make. And then we got to copy. And then we got to go over and clean and then build. So everything's already in our bash history. That makes it pretty quick. Go over to the demo, run the clean, do the flash. This should probably hit the error by now. If not, I may have, voila. Yes, we've hit the error. So go back over to and we say git bisect bad. And we have one last thing to test, right? To see if this also has the same problem. Because if you remember, when we bisected last time, there was one revision left to test after this, one more step. Now we're on that last step. So make. And it will build the code, and then we'll copy. It's kind of repetitive, but it's a lot less repetitive than doing it 63 times. And after we find out whether this next step is good or bad, then it will tell us exactly how many steps it took us to zero in on the particular problem. And then after that, we'll enter in our GitHub issue and figure out what happens next. So we copy it into place, go back to the demo, TinyGo clean, TinyGo flash, and is it good or bad? It is, the answer, good. Okay, so that means now we'll go back. Oh, and does it actually execute? Yes, it does work. So cool, we found the problem. So let's go back to here, and we say git bisect bad. And that is the problem right there. This is the first bad commit. The DC1, oh no, wait, sorry, that was good. I screwed up. But it's okay. I think there's a way to fix that. It was actually the commit right before this one. Not this one. It was I should have said git bisect good, not bad. Because it actually did compile. The bad one was the previous pass, which was this commit right here. Let's see if I can get the output fixed so I can at least see that. So git help bisect. Because I think we can skip back. I believe it's skip back. Let's see. I believe it's skip back. No, but it's okay because I did find the actual problem, right? It's in the commit right before this one, right before DC1 FF801. We're almost there. DC. It's right before the D. No, it says it was a pass in order to remove unused code that worked, and it was the parallel compilation that failed right before that for whatever reason. I don't know why it failed. It doesn't matter why yet. What matters is that we document this so that it can be fixed. And I believe this is, well, I mean, the easiest way is just going to be, what I should have done is just copy the SHA, and then I can say git show, and then that SHA. That would have been easier. It's not too late. We just have to scroll back up in our log a little ways. So we're almost to the top, I hope. Oh, actually, it'll be easier just to find it this way. Because this was the last known good. And actually, this is kind of cool because since we haven't done a git bisect reset yet, it's showing us which ones were good. And actually, this is great. This actually shows us the whole process. So this was the first known good. That's the last release, right? And then we did a few passes. The first one we tried this. That was good. We tried this. This was good. Right? And it was actually in the, where was that parallel? This actually was not, I think it was after this. It was the commit right after this. That was the problem. So let's do a git bisect reset now. So we can go back to how everything was. And so now if we TIG and we go to look for that commit, you'll see that this was the commit that we thought was that I accidentally marked as bad, but that was actually good. This is the actual commit that causes the problem. So we can copy this information, and we can go and we can create a GitHub issue in the TinyGo repo. This way, someone can actually take a look at this, probably Ica. And so we have a new issue, and the problem is compile failure. I'm going to copy the SHA in first, because the actual thing we were testing is the scanner BLE demo that was part of the FOSDEM. And the actual problem we hit is this compilation error. And that's what we want to put into the GitHub issue, right? So a regression bug was introduced with, and that's the SHA. And let's put in the output here. And the code was that I used in my FOSDEM 2021 talk on the Adafruit clue. And let's provide a link to that. That way it's a little easier to find. And I believe, yes, here we go. That is my repo. And this is the demo. That way I can give Ica, or whoever it is who works on this, probably him, since I believe that he is the one who committed the original code in question. And, okay. And compile failure, how would we say? Compile or regression. Or compiler? Yeah. I think compiler, regression failure. Let's say that. Compiler. That way we have a category into which it is. And regression failure for build on Adafruit Clue demo with ST7789 display. I think that's probably, let's just make sure it's formatted okay. Oh, as determined using git bisect. That way he knows where it came from. And it's a bug. Tagged with a bug. And there we go. Whew. Boy, it's a lot of work to track down a bug of the actual compiler itself, right? Especially when there's that many commits. But really, it wasn't that bad. I mean, if we go back and we take a look and we see from that history we were looking at, how many git bisect operations did it take in the end? I lost count, but we can go back to that log and tell. I think it was 5. I want to have the right number just because, numbers are important. Was it 5 or 5 million? So let's see. Somewhere way up in my bash scroll. Actually, I won't be able to find that only because that was part of TIG, and TIG is an ncurses application, and it probably wiped out the screen buffer when it exited. So, oh well. But I think it was about 5 or 6 out of 63. So not bad. That reduced it to about 10% of the work that it could have been if we'd done a brute force search. So I didn't get to do a couple of the other things I wanted to do this week, actually, which was to add a new feature to GoCV. Last week I had mentioned that we have a new initiative going on for GoCV to add CUDA support, which is support for the hardware acceleration in NVIDIA GPUs. But I didn't actually get a chance to do that this week because we got way down into the hardcore debugging weeds. But a good thing to do. We learned how to use git bisect. We found a problem in the TinyGo compiler that was introduced since the last release version was given out. So that's pretty important. We want to get to work on that. So that's pretty great. We got to take a look at Tobias's awesome new book that I think is just about to come out. We got to play a little bit with the Bluetooth scanning on the Adafruit Clue, and we got to take a look at TinyTerm. So that's pretty powerful. That's some pretty cool stuff we can actually do with that with different displays. It will work on other displays as well. I think we have about maybe 4 or 5 different displays that have hardware scrolling buffers. Basically, if you don't do your scrolling in hardware, it's just too slow. It looks kind of jerky. It flashes. It just doesn't look good. That's why we need to use hardware-based scrolling. And so next week, hopefully we will get a chance to play with the GoCV stuff. Also, I will either bring a machine with a GPU, or I will have remote access to a machine with a GPU because we're going to need to run our unit tests, of course. That's not going to do much good at all, right? If we don't actually run the tests. That's what I'm going to do. So if you out there in Internetlandia, you decide, hey, Did Program, I want one of those cool GoCV stickers. Where did I put those here? Wait, pull one out. I want you to know what you're working for. Here we go. So this is one of these, not rare, but neither rare nor easy to come by. See if we can get the focus a little better. That way you can see how gorgeous this sticker is. Focus. Hello, focus. So this is an awesome sticker created from artwork by the always amazing Ashley. So many people don't know that she's a brilliant technologist. They think that she's an artist, which is also true. So this is actually created using the fantastic Gopherize Me. Gopherize.me is a website created by Ashley McNamara, and who else worked on that? Somebody, trying to think of who's it. Well, anyway, it's an open source project that lets you create your own Gopher logos using nothing more than a web browser. So, of course, she offered to create a custom logo. I said, you already did. So we used open source to create open source. Now, these awesome steampunk glasses, there's probably no one else who looked at those and thought, that is the logo for us. I looked at it and I assumed Ashley had made it specifically for this project without even knowing that this project existed yet. So anyway, you can get one of these amazing stickers if you only thing you have to do is create a pull request for GoCV. So next week, I will show you exactly how to go about doing that. If you want to see a little more information about the initiative, you can go to our blog post, which came out a couple of weeks ago. Here, could we do it? Yes, we can. So we're really, really pushing for serious hardware acceleration with GoCV, computer vision with Go, using GPU hardware acceleration. That way your AI applications for computer vision use the full firepower of this operational vision system. Whew. You could tell I want it bad. So we're going to make this happen. I'm going to show you how to do it with a sample pull request. We'll actually run all the tests. We'll see it all work. And it'll be pretty cool. So we'll do that next week. I went to do it this week, but we had a really good session, I think, learning some deep, dark secrets about Git bisect and also how you can use it when you're testing hardware. So what else do I have to tell you? Not too much else. I think it's been a pretty great week. Join us on our Gopher Slack. Join us on Twitter. Join us in our repo with commits. Join us in any way, shape, or form you like. And on that note, my Gopher plushie and I bid you a lovely evening here from northern Spain, Asturias. We say adios until next time.
Computer Liste, Computer Liste, everybody in the gas get flat. Computer Liste, Computer Liste, Computer Liste, Computer Liste, everybody in the gas get flat. Computer Liste, Computer Liste, Computer Liste, Computer Liste, everybody in the gas get flat. Computer Liste, Computer